We distributed the x first, and then we distributed the -4, and what happened was our middle terms canceled out. So we ended up with x squared minus 16. We're going to go back to number 1. In number 1, you're just distributing the 3. So 3 times x gave you 3x, and 3 times -5 gave you -15. How are you guys doing so far? Okay. This one was tricky because a lot of people wanted to put the squared on each term. It doesn't distribute like that. The squared doesn't distribute. What it does do is it multiplies x minus 7 by the same thing. So 3 squared is 3 times 3. X minus 7 squared is x minus 7 times x minus 7. Now, if you didn't write something like this, that is your first step. Please do that. It looks a lot like this one, but my middle terms are not going to cancel out this time because both of my 7s are negative. In this one, I had a negative and a positive. So this time when I distribute, I still have x times x is x squared. X times -7 is -7x. Another -7 times x, so another -7x. And then negative times negative is positive 49. What questions do you have on that step? Let me move it up. You know what? I'm even going to turn off more lights. This one? That didn't do anything. Oh, wait, I have to do this first and then this. Okay. All right, so I have to combine like terms. The -7s combined, they do not cancel out. They make negative what? -14. Okay. Questions on that one? Okay. For number 4, I'm going to show you a different technique. Has anybody ever multiplied using the box technique? Anybody read? You did? So the box technique is just another way of multiplying. You never have to use the box technique. Some people just like it. So let me show you what it looks like. You make a 2x2 box. Like that. It's just a different way of multiplying. You can solve this problem the same as this one. Okay, but this is just something new to look at. You put one of the binomials on the top, x plus 7, and the other one on the side, x minus 3. And then this just kind of helps you organize your multiplication. So x times x is x squared. X times 7 is 7x. -3 times x is -3x. And -3 times 7 is -21. All right, back to recording. So now we're going to combine our like terms. So I still have x squared. These two combine to give me 4x and then minus 21. Okay, so you see how it's really the same exact thing as distributing. It just is another way of organizing your work. All right, in the last one, there's a lot of different ways to go about this. Raise your hand if you ignored the 4 to start and you just multiplied x plus 1 times x plus 2. Anybody start that way? Nobody? All right, raise your hand if you ignored the x plus 2 and you started by distributing the 4 to the x plus 1. A lot of you did that one. Okay. That's fine. Either of those is acceptable. The one thing you want to avoid is when you have the 4 here, you cannot distribute it to both the x plus 1 and the x plus 2, because then you're actually multiplying by 4 twice. 4 times 4 is 16. So instead of multiplying by 4, you multiply by 16. So you can multiply these two first, completely fine, or you can distribute the 4 to one thing first. So I'll show you that one, because that's what a lot of you did. You distributed the 4, and you got 4x plus 4. And then you keep the x plus 2. Then 4x times x, 4x squared. 4x plus 2, or times 2 is plus 8x. This is 4x. And then this is 8. Is that what you guys got so far? Yeah. And then combining like terms. All right. So I want you to take a minute to compare your work with your group. Some of you worked very closely with your group, so you definitely did use the same methods, but some of you may have used different methods, especially in this last problem where there's different ways. So I want you to write down, I use the same methods, or in number 2 or in number 5, we use different methods. What was the same about your methods and what was different about your methods? So take 1 minute to do that. Most of you guys said you use the same methods, so then they're just completely the same. Let's go to the back. Yep, on the back. All right, to factor means to undo multiplication. So these problems are inverses of the problems on the front. Look at the front again. If this was the problem, 3x minus 15, I could factor out the 3. That would come to the outside. And my answer would be 3 parentheses x minus 5. So factoring is undoing the multiplication, taking it back apart into its pieces. Okay? So let's look back. In this problem, I could factor out a c, but I want to factor out the GCF. GCF is greatest common what? Factor, right? Greatest common factor. So I have to think, what is the biggest number I can divide 6 and 24 by? 6, yeah. So I'm going to factor out a 6. So the 6 comes here. And in the parentheses, I'm going to have 2 terms. To figure out what those terms are, I'm going to undo the multiplication by dividing by 6. When I divide the first one by 6, these cancel and I just get x. And then 24 divided by 6 is 4. Do you see how that problem is backwards of the problem 1 on the first page? We started with the multiplied answer, and then we ended with the 2 pieces. It took it apart. We factored it. You could check and see if you were right by multiplying. 6 times x is 6x, and 6 times negative 4 is negative 24. So you can always check, but this is the answer right here. All right, so one of the things we're learning about today is GCF factoring. There's another one called difference of squares. Okay, difference of squares is factoring when you have 2 terms. This is subtraction, and they're both perfect squares. How can you tell if they're both perfect squares? 6 times 6 is 36, so that makes 36 a perfect square. Good. And how about x squared? Is x squared a perfect square? Yeah, because it's squared, right? All right, so these are both perfect squares. The pattern for perfect squares is a squared minus b squared equals a minus b times a plus b. Take a moment to write down that pattern. So a squared is this x squared. So if I want to know what a is, I do the square root. So a is the square root of x squared, which is x. B is the square root of 36, which is 6. So now that I know what A and B are, I just substitute them into the formula. So instead of A minus B, I write X minus 6. And instead of A plus B, I write X plus 6. Oh, the last thing we're going to talk about is simple trinomials. Simple trinomials. It's called a trinomial because it has how many terms? 3, right? Tri means 3. All right, so let's look at the first one. This is the one you might remember more. You're looking for two numbers that multiply to the last number and they add to the middle number. So multiply to 81 and add to negative 18. So when I'm looking for numbers to multiply to 81, I usually make a list. You guys think it's any cooler outside? Let's try it. We'll see if it helps. You tell me, okay? All right. So 81, it could be 1 times 81, 3 times 27, 9 times 9. These are some ways to multiply to 81. Do any of these add up to negative 18? 3 and 27? 9 and 9 is getting close, right? Because what's 9 plus 9? Is 18, but I need negative 18. A negative and a positive, let's see. I think you're thinking on the right track. A negative times a positive, though, will give us a negative 81, right? Who can build on that idea? What was it? 2 negative numbers? What do you guys think about that? A negative times a negative is what? Positive. And then if we add them, it's negative, yeah? Yes.
Negative 9 times negative 9.
Okay. All right. So you guys, I think together, teamwork, we came up with the negative 9 and the negative 9. So negative times negative is going to give me that positive. So here's how your answer is going to look. The x squared comes from x times x. The 81 comes from negative 9 times negative 9. The negative 18 is what we get when we have a negative 9x and another negative 9x. So you see that? The negative 18x is the negative 9x and the negative 9x. So if you multiplied x minus 9 times x minus 9, you would get x squared minus 18x plus 81. Number 9 is the same kind of problem. So we're looking for numbers that add to 6 and multiply to negative 16. So maybe negative 1 times 16, negative 2 times 8, negative 4 times 4. And of course, you can switch up which one's negative. So it could be 1 times negative 16, 2 times negative 8. This would be the same though. So what I want you to do is figure out which pair of numbers adds to 6 and then set up your parentheses. I saw a lot of you realize that this is the pair of numbers that adds to 6. Negative 2 plus 8 is 6. So then when you set up your factor pairs, x squared comes from the x times the x. Negative 16 comes from the minus 2 and the plus 8. And the 6x comes from the two middle terms combined. What questions do you have on 9? Okay. Number 10 is different because it's a two-step problem. In every problem, you should be looking for the GCF first. We didn't really look for a GCF here, but it was good because there wasn't one. There's no number that divides all three terms because the first term doesn't even have a number, and they don't all have x. But if you look at number 10, they can all be divided by what number? 3. So your first step is to factor out the common factor of 3. So I'm going to divide 3, 3, and 3. Okay, when you divide everything by 3, This is what we're left with. And then you're going to do the simple trinomial. We have to figure out what multiplies to 20 and adds to 9. And I'm going to give you a few minutes to do that. Figure out what multiplies to 20 and adds to 9. Let's see how you did on this one. To multiply to 20, I saw you guys try a lot of things. 1 times 20, 2 times 10, 4 times 5, and then you found it, right? This one? All right, so then you have x plus 4, x plus 5, and then what do I have to put in front? What number am I missing in front? 3, yeah, put the 3 back. All right, and you know what? We worked together on those, so we don't have to say anything about different methods.